Alright, welcome back to the channel. My name is Lian Duan, and I'm a content creator based here in Maryland. My goal with the channel is to be a resource to DevOps creative thought, tutorials behind the screen content, and honest podcasts. If you are into that sort of thing, make sure you subscribe to join the creative crew. It goes a long way towards supporting this channel, and it makes sure you never miss out. All video written Markdown and access YAML files are on my GitHub. The links are below. Today I will introduce Kubernetes Network Policy and run hands-on demo. After you finish the video and exercise, you will understand Kubernetes Network Policy and how to use network policy on 3 layers microservice app. Video topic is hands-on demo environment. What is Kubernetes Network Policy? Analysis demo app network traffic. How to add network policies to the demo app. First topic, my hands-on demo environment. My demo environment is based on Ubuntu 22.04. Docker version is 20.10.16. My Minikube is based on Docker, and the Minikube version is 1.25.2. The Helm 3 is used to install my demo app. The Helm 3 version is 3.9.0. My demo app has React UI microservice, Spring Boot microservice, and Redis is used to store user information. The end user can add, delete usernames, such as first name and last name, and the app will show usernames in the list area. User access www.helm3training.com to render single-page application front-end microservice, and single-page application will call api.helm3training.com to reach backend microservice. As I mentioned, backend microservice store the data in Redis DB. The demo app detail is in the video. 3 tiers application overview. The link is below. Next topic, what is Kubernetes Network Policy? Kubernetes Network Policy is used to namespace level to isolate pod network traffic between namespace and inside namespace. Kubernetes pod network workloads are not dependent on the physical network devices such as routers, firewalls, etc. You can think of network policy as virtual firewalls. It's applied to the pod in real time. Kubernetes Network Policy needs network plugins to support. For example, Colic Romana View. As you know, the Kubernetes network model is flat. The default network policy allows pods to communicate with each other. The front-end microservice can talk to the back-end microservice, even the Redis pod. That's not secure, so I have to use Kubernetes Network Policy with label selector for define which pod can talk to which another pod. How to create a Kubernetes network policy? We have to familiar with the network policy syntax. There are 5 key points in Kubernetes network policy create YAML file. The first item, metadata. Metadata include Kubernetes network policy name and related namespace. The Kubernetes network policy name is backend DB Redis. Namespace is qn-env. Second item, pod selector. Pod selector defines network policy to apply which pods. The Kubernetes network policy will apply to the pod which has label key is app, value is backend DB Redis. Third item, ingress and egress. Ingress means inbound rule, and egress means outbound rule. Next item, ingress rule detail. Ingress rule has IP block, namespace selector, and pod selector. IP block can control access from outside Kubernetes cluster. IP block cannot use to pod level because the pod IP is not static IP. Namespace selector is used to control network traffic from all pods of different namespace. Pod selector can select specified pods from the same namespace or different namespace. There is example. If the pod has a label IP colon backend Spring Boot microservice and debug colon Redis client. The pod can access Redis pod on port 6379. The three rules are grouped by AND or logic. Latest item egress. Egress has the same rule and logic as ingress. The backend Spring Boot microservice allows outbound network traffic to an app which has a label app equal to backend DB Redis. The port is 3679. The egress and the ingress allow two-way standard traffic between backend Spring Boot microservice and Redis on port 6379. We pass the network policy concept. Next topic is the demo app network traffic analysis. Network policy creating is based on the network traffic workflow and pod. Let's analyze my demo app. There are three network traffic groups. We go through them one by one. First, find the pod network traffic in the same namespace. In my demo app is item 1. Backend Spring Boot microservice and the Redis pod has two-way network traffic on port 3679. Second, find the podnet traffic in a different namespace, such as item 2. All pods access core DNS of kube system namespace. If your system has permissions or elective search, they have to network traffic across different namespace. Third, find the pod network traffic with the outside cluster. For example, an user access www.helm3training.com to single-page front-end microservice and a single-page application called api.helm3training.com to reach backend microservice API. The two network traffics are from outside cluster. Also, the ingress resource and the service resource are not part network policy because the two resources just routing network traffic. We jump into latest topic, hands-on demo. Add network policies to the demo app. Since I'm using Minikube for the demo, I would need a network plugin calling on Minikube. By default, CI add-ons is not part of Minikube start. Log into my demo box. Go down to the YAML folder. Open Helm subfolder. Start Minikube with CI plugin calling. Enable ingress plugin for my demo app. Also, add www.helm3training.com and api.helm3training.com are into /etc/host file. Next step, run helm3 command to install my demo app. The command is helm install. Release name is my app. Helm's file folder is current. Namespace QNENV. Wait, all the resource created. My app created. Then go down here. Check demo app status. Remote login to my Linux box. Open browser to access UI. Address is www.helm3training.com. UI is rendered. Try add user. First name is Peppa. Last name is Pig. Close the remote desk. Next, create a Redis client pod to access Redis DB. Command is kubectl run pod name Redis client. -rm means after stop, the pod will be deleted. Open the interactive terminal. Namespace QNENV image detail. Endpoint is /bishop/sh. The Redis client command to connect Redis DB. Host is a Redis service name. Backend DB Redis. Port is 6379. Connect, no issue. Back to the Redis client pod. And then apply network policies. With screen bigger, we go through the 4 policies. First policy. Deny all network traffic in QNENV namespace. This important default deny policy. You should add this default denied policy for your namespace. Second policy, backend DB Redis. Redis pod only allow pod which has the label app : backend Spring Boot microservice access. The port is 6379. The protocol is TCP. Also, Redis pod allows outbound traffic to Kube DNS. The port is 53. The protocol is UDP. Move to third policy. IP block is used to allow outside Kubernetes traffic to the backend Spring Boot microservice pod on port 9999, and the port can talk to Redis on the port 6379 and DNS on port 35. Fourth policy is front-end app React UI microservice. I'll keep point covering the previous policies. If you have any questions, put the comments below. All the policy files are in len-network-policy.yaml. Open terminals. Open the YAML file folder. Run command kubectl apply -f plus YAML file name to apply the policy. 4 policies are created. After applying network policies, final step, verify my demo again. Go back to the UI, add user, daddy pig is added. Close the terminal, switch to the Redis client pod, try to access Redis DB. Run the same command to connect to Redis DB again. We're facing timeout. That is right behavior because it doesn't have need labels. There is also related command in my demo. The hands-on demo finished, and all topics are completed. Today we learned Kubernetes Network Policy concept, how to analyze app network. Based on the analysis result, run hands-on demo to create 4 network policies and apply them to the QENV namespace. Also verify network policies. Thank you for watching the video. See you in the next time.